Hi, today we're going to go through the using properties of water to introduce students to statistics lab. So I have some distilled water, I have some rubbing alcohol, I have some salt water. I also use distilled water in here and some distilled water with some soap in it. If you need minimal tools at home to get this done, you need a penny, and I have an eraser because the best way to clean the penny is just to give it a good erasing. Dropper, and I have some paper towels because we do have to dry the penny in between um, each go. Alright, so I've cleaned my penny. I'm going to look at the lab packet. And it says to obtain a dry penny using a dropper, drop distilled or DI water onto a penny 1 drop at a time and count the drops. Record how many drops you were able to place on the penny before it overflowed. Record this number in the data table provided on the next page. Dry the penny and repeat for a total of 5 trials. So I'm going to do this 5 times. So I've got my penny, and I'm going to adjust the camera. Let's see here. All right, distilled water. Let's give that a little focus. That'll take a second. All right, so penny, and let's see, hopefully you can see the water kind of bubbling up. So using some of those cohesive and adhesive properties. So we're going to drop this. 1, 2, 3, 4, 5. You can see the water just kind of coalescing there. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I'm going to pause. That's pretty cool. Okay. 18, 19, 20, 21, 22, 23, 24, 25, 26. Let's get some more. Whoa, 27. Alrighty. So it spilled over 27 drops. All right, I'm going to clean this off because it says to dry your penny and repeat for 5 trials. So I'm going to dry this penny. We don't want any water left on there. And alright, I'm going to go ahead and run the trials. Alright, so I've run this a few more times. So I've got 27, 21, 24, and 31 drops. Let's see how this one goes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. All right, there we go. 29 drops for that one. All right. All right, so before we put the rubbing alcohol on the penny, you're supposed to predict the number of drops of rubbing alcohol a penny will hold and justify your prediction. So I'm going to look at these command terms and predict Predict the cause or effects of a change in or disruption to one or more components in a relationship, pattern, process, or system. So changes or effects of the change, what might cause the amount of drops of rubbing alcohol that we can fit on this penny to be different from the distilled water. And then it says to justify your prediction. So provide evidence to support, qualify, or defend a claim, and or provide reasoning to explain how that evidence supports or qualifies the claim. Okay, so we want to pause the video and predict the number of drops of rubbing alcohol a penny will hold and justify your prediction. Rubbing alcohol is carbon, hydrogen, and oxygen. So how might that affect the number of drops that we can get on top? All right, I'm just cleaning my dropper. It only had water in it, but I want to get all the water out. All right, here we go with round one. How many drops? This is after you wrote down your prediction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There we go. 16 for that first one. Let's use a different color. 16. All right, so let me clean that up. All right, round 5, rubbing alcohol. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There we go, pretty consistent. Get that cleaned up. All right, I have a new dropper, so I don't want the rubbing alcohol mixing in with this distilled water. So this is salt water, so sodium chloride. Okay, repeat steps 1 through 4 with the same penny, but this time with salt water. Predict the number of drops of distilled water a penny will hold if dish. Okay, I was making sure I read this right, and I was reading the wrong thing. So, salt water on a dry penny. Here we go. After you made your prediction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 21, 22, 23, 24. There we go, 24. Okay, write that down before I forget. 24. All right, let me clean that up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 that time. All right, so we got 24, 17, 26, 23, and 22 for that salty water. And actually, I'm going to clean up my dropper a little bit with some distilled water because I do not want any salt in here to mess up the next one. Okay, so I originally had soapy water, and that was because I didn't read clearly. This one is predict the number of drops of distilled water a penny will hold if dish soap has been spread on its surface, and justify your prediction. So I'm going to get a little bit of soap on my finger and just a little bit. Rub it on the soap. All right, make some predictions. Predict and justify. What do you think? How many drops will a soapy penny hold? How many drops of distilled water? So I'm going to grab my distilled water. Back over here. Let's get down close. So I've got soap rubbed on that penny. All right, distilled water on a soapy penny. Did you make your prediction? If not, pause the video. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. There we go. 12 for the first one. All right, so this is round 5. Something that I've noticed, I'm just trying to put one little drop of soap on the penny, because earlier I got 2 drops and it didn't hold much water. All right, so I will reveal my numbers in a moment. Let's do this round 5 for the soapy penny. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10. I did dry the penny between each one and reapply fresh soap. Okay, so I got 12, 10, 8, 11, and 10 drops of distilled water on a soapy penny. If you remember when we were talking about a cup of water and surface tension, and you can sprinkle some pepper on top and it'll stay floating unless you add a drop of soap, which disrupts those hydrogen bonds, and then the pepper will sink to the bottom. All right, so here are our numbers. Let's go up and up some more. All right, that's at least in the view. All right, distilled water right here, rubbing alcohol, salty water, and a soapy, that's actually a soapy penny, isn't it? So let's just fix that. Soapy penny. All right, we will discuss the rest of the lab in class. See you. Bye.